Hey, hi everyone. In the previous video session, we discussed some very basic pattern printing problems. For example, the ones which are shown on your screen. We discussed a basic pyramid printing, a diamond, and then I gave you a homework problem also, which was this one, a reverse diamond or reverse rhombus. Now, in this problem, in this session, we discuss this. Let me just give me a second. Okay, I think so. I won't be spending too much time on reverse rhombus problem. I will just give you a general idea. If you were not able to solve it, use this idea to solve. Now, first, if you will see, similar to rhombus, you can divide this reverse rhombus into two parts. This is the first half, then this is the second half, which is reverse. Sorry, this is the first half, and the second half is the reverse of first half. We are exactly printing the same pattern but in reverse order next time. Now we can simply assign indexing to the rows. I am using indexing from 0. You can use from 1 also. Uh, so these are 0, 1, 2, 3, 4 indexes for the row. Then I am comparing it with the number of stars I am printing in that row. In 0 row I am printing 5. In one for row number 1 I am printing 4 stars. In row number 2 I am printing 3 stars. In row number 3 I am printing 2 star. In row number 4 I am printing 1 star. Now why I am using indexing from 0? Because if you will use indexing from 1, the sum will result into n plus 1. But this way it's resulting into n, so it's slightly easier for you to visualize. So it will be better if you use 0, but you can use I from 1 also. Now if you will compare the row number and stars, you can see that the sum of row numbers, that means I plus j, I'm using j for stars, will always be equals to n. So you can simply say j is equals n minus I. That means you can use this variable for running your internal loop for the stars. Then comes spaces. If you will see, in first row there's one space, in second row there are three spaces, in third row there are 1, 2, 3, 4, 5 spaces. Similarly, 7 and 9. Now we have already dealt with this kind of arithmetic progression in one of the previous problems. If you will use the sum of AP formula or else simply correlate it, you can formulate this formula 2i plus 1. Then again we are printing same number of stars as we printed before these spaces. In every row, the number of stars before and after the spaces will be same. So nothing different. Again, we'll be doing n minus I. I hope you will be able to solve it. Please revise these 4 steps before continuing with this session. It will help you solve the problems. Then let me move to the last problem for this pattern printing sessions, which is a really complex pattern to print. So let's see how we can simplify it. Let me erase this all stuff. Just give me a second. Oh, my bad. So let's see how we can solve this one. Now, first of all, I'm looking at the pattern and trying to analyze that can we divide it into two parts. Since this pattern is x, 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 x being printed repeatedly, so as it's very simple to see that x could be divided into the top half and the bottom half. So we can divide this pattern into the first 3 rows and the last 2 rows in case of n equals 5. Similarly, for n equals 7, we would be able to divide it into first 4 rows and last 3 rows. And similarly, for n equals 3, first 2 rows and last 1 row, and for every n. And remember, for this type of problem, n would always be odd. Now, this pattern is not possible with n being an even number. So, let's see how many rows are there in the first half of the pattern, or let's say the first part of the pattern. So we can say size of first, or let me simply say I, or let's say I loop. What will be the number of iterations for the I loop? So number of iterations for the I loop will be n divided by 2. That means for 5 it will be 5 divided by 2 will be 2. So we can say n divided by 2 plus 1 iterations. Okay. So these are the number of iterations. We can say n divided by 2, my bad, n divided by 2, that means we'll be going till n divided by 2 because we are starting from zeros. So if we'll start from zeros, the I loop will be going till n divided by 2 because we have n divided by 2 plus 1 iterations. So since n is 5, we'll be going 0, 1 and 2. I hope you're getting it. Then let's see what's the, let me write it here, 0, 1 and 2. Now in zeroth row, if you will see, we are printing stars. Now if you will try drawing patterns with n equals 5, n equals 3, n equals 7, n equals 9, you will be able to see the total number of characters in every row are n into n. For example, in this one, if you will count, it will become 25 characters. And I am using this indexing 0, 1, 2, 3, 4, 0, 1, 2, 3, 4, 0, 1, 2, 3, 4 because I am interested in finding the modulus with n. Now I am coming to that why we are finding modulus. If you will look at the pattern, if you will observe it deeply, we are printing a star for 0, then for 4, then for 5, then for 9, then for 10, then for 14, then for 15, then for 19, then for 20, and at last for 24. So you can see we are printing stars for indexing either perfectly multiple of n or 1 lesser than that. 0, 4. Now 0 is perfectly divisible, 4 is 1 lesser than a multiple of 5, 5 is perfectly multiple of 5, 9 is 1 lesser than that, 10 is perfect multiple. Similarly, if you will see in the next row, then also you will be able to find a pattern 1, 3, and it is 4, 5, and 6. After 1, 3, it's 6, then 9, then it will be 11, then it will be 13. So if you will try finding the modulus for these ones, it will always be 1 and 3. So I found a correlation that I am getting. I am printing a star for a particular modulus, for a particular, for a indexing which has a particular modulus when divided with n. So I am saying I am printing stars in first row for n, or not, my bad, j, which is the indexing for the internal loop. Mode n is equals either 0 or j mod n is equals 1. Then in next row, let me copy this so that we don't have to put too much effort. In next row, I am saying if j modulus n is equals, my bad, it was 0, then 4, then 5, then 9. So the remainder was either 0 or 4. In this case, it will be j modulus n is equals either 1 or 3. Then in last row, it will be j modulus n is equals 2. Now, if you will try to find the correlation for I is equals 0, j modulus n is equals 0. For I equals 1, j modulus n is equals 1. For I equals 2, j modulus n is equals 2. Then this 4 and 3, if you will find a correlation with n and I, it will become if j modulus n is equals either I or j modulus n is equals n minus I minus 1. For example, in first row, it will be 5 minus 0 minus 1. That means 4. In second row, it will be 5 minus 1 minus 1. That means 3. So in this cases, we are printing stars, else, now spaces. I'm writing else here. By else, I mean that if we are not printing star, then for all those cases, we'll be printing spaces. So now some of you might be thinking that I have said that you have to follow this approach, but how you will be able to visualize it? Now, this is the most tricky part when it comes to pattern problems. As you will be solving more and more complex problems, it won't be easy to visualize the logic, the correlation between the characters you are printing. But that's the most tricky and difficult part to learn. But trust me, if you will practice more and more problems, you will be naturally able to visualize it. I haven't, when I solved this problem first time, I haven't visualized it by reading some uh, conceptual by reading something conceptual related to this or reading someone's code. I just looked at the pattern and decoded it and formulated this approach. But trust me, when I started with patterns, it was very difficult to even decode a basic pyramid problem or a rhombus problem. So practice is the key for understanding how to build approach. So let's move to the coding part without wasting much time. Let me write the code from beginning. So first we are taking a variable n, we are taking input for n, then we are running a loop. Now we have divided the problem into two parts. I am discussing the first part only. We will come to the second part later. So I am saying for integer I is equal to 0, I is lesser than n divided by 2 plus 1. Let's say why we have to complicate it. N divided by I is lesser than or equals n divided by 2 I plus plus. This is the number of iterations for our external loop. That means the number of rows, zeroth row, first row, and second row in case of n is equals 5. Then for every row, what we want to do for integer I is equals 0, as I already told you, if you will count it, even not just for 5, for something else also, these number of characters will always be n into n. So, my bad, for integer j is equals 0, j is lesser than n multiplied by n, j plus plus. And if j modulus I, my bad, if j modulus n is equals I, or j modulus n is equals n minus I minus 1. In these cases, I want to print a star. Now, in my case, I am not using any extra space, but in some problems, they might want you to print an extra space. Then you have to add an extra space in both the print statements. Okay, we have done this. Now, after completing one full iteration of the internal loop, we'll be printing a new line because now next we'll be dealing with the next row. Let's see it works or not. Let's first see for the n equals 3. It's working fine. Let's test it for 5. Okay, it's working fine. Let's test it for 7. Oh, I think we need more space. Yeah, it's working fine. So now let's see how we can handle the latter part. Now, if you will see, the latter part is nothing else than just reverse of whatever we printed in the first 3 rows. Now, we are printing first this row, then this row. Oh, my bad. First, we are printing, yeah, first we are printing this row, the 1 row, then we are printing the 0 row. That means the row with 1 index, then row with 0 index. So that means we are printing in reverse, but we are not printing the last row. As if you will add this row again, it won't look like X, it will be slightly different. So we don't want to repeat the last row. For rest of the row, we want to run a reverse loop. So let's try to reverse the same loop. We did the same thing with the rhombus, or let's say the diamond problem. That same thing we are doing with this one also. Nothing different we have to do. Let me say a reverse part starts from here. So we can copy the same code, just reverse the external loop. I'm saying for integer I is equals n divided by 2, I is greater than or equals 0, I minus minus. Now we don't want to print the last row. So if you will say n divided by 2, you will be printing the last row as well. We'll say n divided by 2 minus 1. Rest everything will be same. So let's run this code. It's working absolutely fine. For n equals 7, we can try for n equals 5 also. It's working absolutely fine. I hope you understood all the pattern problems, and after watching these two video sessions, you will be able to solve any pattern problem under the sky. Bye bye. Thank you. I'll come with lot more stuff which could be helpful for you people in your programming journey.